Let's practice solving quadratic equations that are written in standard form together. For these particular 8 practice problems, let's go ahead and practice solving each of them in the most optimal or efficient method using the quadratic equation, factoring, square roots, or completing the square. Let's get started. Generally speaking, I think if you're going to go ahead and choose which of these methods to start with, we should always look at square roots first because that method can be very quick, then try to see if we can factor if we can't solve by square roots, then completing the square, and finally the quadratic formula, which generally takes the longest. For number 1, we have the equation x squared plus 6x minus 11 is equal to 0. So let's start by thinking about square roots. Now, when we're solving by square roots, we generally like when b is equal to 0, but in this case, b is equal to 6. So I think we're going to say no to solving by square roots. Now, what about factoring? Well, we got to think about our factors of negative 11, which are just 11 and negative 1 and 1 and negative 11, and see if they would add to get to positive 6. But I don't think that's going to happen. And again, that's going to work here because a is equal to 1 here. But in this case, I think we're going to say no to factoring because we're just not going to be able to come up with any factored binomials that we can write here. Next, we should consider completing the square, and I think this one's a good method to use if the b value is even. So here you can see that b is equal to 6, and that's an even number, and it was already not factorable, and we can't solve by square roots. So based on that, I think that this is a good candidate for solving by completing the square. So here we have our original equation. When we complete the square, what we're going to do is start by isolating the c value, or the constant term. Let's go ahead and add 11 to both sides. When we do that, we're going to have x squared plus 6x, and we generally just leave a little blank here because we need to complete the square, and this is going to equal positive 11 on the other side. Now, to complete the square, what do we actually do? We take a look at the b term of 6 here, so we can see b is equal to 6, and we take that b term, and we take that 6, and we divide it by 2, or cut it in half, and then we square it. Now, 6 divided by 2 is 3, now 3 squared, that's going to equal 9. So 9 is going to be the value that will complete this square. We go ahead and add a 9 to the left side of this equation. We must go ahead and add 9 to the right side as well to keep it balanced. And so by adding 9, we just completed the square on the left side. So what this is going to factor into is going to be the binomials of x plus 3 multiplied by x plus 3, which is going to be a perfect square there of x plus 3 squared. I'm just going to write it out expanded right now. And then on the right side, this 11 plus 9, that's going to equal 20. Okay. On the left side, we can go ahead and condense these two identical binomials. Since it's two of the same thing, we can just write x plus 3 squared, and that's going to equal 20 on the right side. Here we can see that we have a perfect square isolated on the left side, so we can go ahead and take the square root of the left side of the equation, and we can go ahead and take the square root on the right side as well. On the left side, we're going to be left with this x plus 3 when we take the square root, and on the right side, we're going to have plus or minus the square root of 20. When we see a radical like the square root of 20, we should see if we can simplify that. Now, let's see what perfect squares go into 20. So I think we can say the square root of 4 times the square root of 5, since 4 is a perfect square. Now the square root of 4 is going to just be 2. So we're going to have 2 times the square root of 5. So based on that, we're going to say that this is going to be x plus 3 is equal to plus or minus 2 times the square root of 5, which is just a simplified radical version of the square root of 20. Finally, let's go ahead and take away 3 from both sides of the equation. And so our two solutions here are going to be x is equal to this negative 3 plus or minus 2 times the square root of 5. Now, if we want to go ahead and write this in kind of our solution set notation, we can go ahead and say that the two solutions here are going to be negative 3 plus 2 times the square root of 5. And we can also say it's going to be this negative 3 minus this 2 times the square root of 5. Let's try another one. Here is number 2. We have the equation x squared minus 4x minus 12 is equal to 0. Now let's see if we can solve by square roots first. Now if we take a look here, we can see that our b value is equal to negative 4. So since we have a b value, it's not 0. I don't think solving by square roots is going to be very efficient here. Now next we can go ahead and see if we can factor. Okay, so keep in mind that we do have an a value of 1. So we got to think of factors of 1 multiplied by negative 12, which is negative 12. Are there factors of negative 12 that add to get to negative 4? Well, on the side here is what I'm going to write. This is my method that I like using, but feel free to use a different method. I know that we're going to have 1x and 1x because that's what's equal to that 1x squared. And then I'm going to choose something like, I don't know, 4 and 3. Now, we know 1's going to be negative because it's negative 12. If we go across here, this would be, and we multiply, that would be 4x and then minus 3x, which is only 1x. That's not what we want. But maybe we can switch this up a little bit. So maybe we can try 1x and 1x, and then we can try something like negative 6 and positive 2. And see if that works. Well, if we multiply across here, that's going to be negative 6x, and we multiply across, that's positive 2x. Negative 6x plus 2x is going to be negative 4x. So we know that we want these two terms to multiply and these two terms to multiply, and that would help us get our binomials, right? So here's what I'm going to do. It looks like we can factor here based on what we just said. And so I'm going to go ahead and just open up two empty binomials. These are going to be our linear binomials and set it equal to 0. And we know that these ones want to multiply by each other, so let's go ahead and make that happen. Now, if we put them in the same binomial, they won't multiply by each other, but if we put them on the outers, they will. Just remember that when you FOIL, you will eventually multiply these outer pieces together, and that's where we're going to get this negative 6x. And now these two have to go together, so we're going to go ahead and put our 1x over here at the beginning of the second binomial, and let's put a plus 2 at the end of our first binomial. So these two pieces here, this would be the outers and the inners, or you can switch them vice versa, that's fine too. But you can check this if you want. Multiplying and FOILing this out, this would be x squared minus 6x plus 2x, which combines to get negative 4x, which is what we wanted, and then this gets us our negative 12. Okay, so at this point we can go ahead and solve this whole thing because we know our zero product property means that each of these binomials has to equal 0. So if we take a look at this one here, what would make this equal 0? Well, if x was equal to negative 2, then this whole binomial would equal 0, then multiplied by the other binomial would also equal 0. For this one, we have x minus 6, so if x was the opposite of negative 6 or positive 6, then this would also cause this linear binomial to equal 0 as well. And so just like that, because this was factorable, we didn't have a lot of work to have to write out here. We know that our two solutions here are going to be negative 2 and positive 6. And these are rational solutions because it was factorable. Here's number 3. For number 3, we have this equation of 9x squared minus 16 is equal to 0. So right away, notice how there is this kind of this 9x squared and then it's plus 0x since we don't see it, and then minus 16 is equal to 0. So based on that, we know that b is equal to 0 here, which is kind of nice for us. So it's actually missing that middle term with the x. And based on that, we're going to go ahead and use square roots here. So when b is equal to 0 and you don't have that x term, we like to solve by square roots, so we can just go ahead and start by adding 16 to both sides of this equation. When we do that, we are going to have this 9x squared is equal to positive 16 on the right side. And then to isolate the x squared, let's get a coefficient of 1 by going ahead and dividing by 9. If we do that, we're going to get 1x squared, or just x squared, and on the right side, we're going to have this fraction of 16 over 9. Let's keep it as an improper fraction, a little bit easier to deal with. And then finally, let's go ahead and take the square root of the left side and take the square root of the right side, since x squared is a perfect square. The square root of x squared is just going to be x, and on the right side, we're going to have plus or minus the square root of 16, which happens to be 4, and the square root of 9, which happens to be 3. So it looks like we have two rational solutions here. We could have factored this as well if we wanted to, but I went ahead and did it this way. I think that's kind of an efficient way of solving this problem. So our two solutions are going to be negative 4/3 and positive 4/3. Those would be our two solutions. Now, on a side note, if you notice that this was a difference of squares, this is a perfect square minus a perfect square, you could have also went ahead and factored this into saying this would be the quantity of 3x plus 4 multiplied by the quantity of 3x minus 4, and you could have solved it this way as well, and you would have gotten the same solution. So maybe this one's slightly a toss-up, but I think when you don't have a b value, or rather the b value is 0, don't want to say you don't have one, I think that solving by square roots is an optimal way of solving this equation. But you could argue, perhaps, that if you notice a difference of squares pattern, that is a more optimal way of doing it. I think it's kind of a toss-up between these two methods. Here's number 4. Alrighty, for number 4, we have the equation 4x squared minus 4x minus 5 is equal to 0. Let's first start by seeing if we can solve by square roots. So let's go ahead and take a look at the b value. Since b is equal to negative 4, I don't think it's going to be very good to solve by square roots. Next, we can go ahead and see if we can solve by factoring. So to solve by factoring, what we're going to do is I'm going to go ahead and take factors of this 4x squared. So maybe I'll try something like 2x and 2x, because that equals 4x squared. And then we have this minus 5 over here. So maybe I'll try something like a negative 5 and positive 1. Now, if we multiply across, that's negative 10x with a positive 2x, that's not going to get us the negative 4x we're looking for in the middle. If we go diagonal, it's going to be the same thing if we multiply because the 2x's are the same. The only other combination we could maybe try here is 4x and 1x. That would also get you 4x squared. And I'm just going to keep this negative 5 and positive 1. I can move the negative if I need to later. That would be negative 20x plus 1x. That's going to be negative 19x. We don't like that. This would be positive 4x and then negative 5x, that equals negative 1x if you combine them, and that's also not what we're looking for. So there are no combinations here that we can get that negative 4x in the middle, so factoring is not going to work. Next, we would go ahead and see if we can do this by completing the square, but in this particular case, generally when there's an a value over here that is not equal to 1, so this is equal to 4, completing the square is just not very friendly. You can definitely complete the square when a is not equal to 1. You can check out one of my other videos on that, but it is quite time consuming and there's a lot more steps to it. So based on that, if we aren't going to use the first three methods, I think this is a good candidate for the quadratic formula. All right, so right away we know that a is equal to 4, we know b is equal to negative 4, and that c is going to be equal to negative 5. This, of course, is our quadratic formula. If you haven't memorized it yet, it's a good thing to go ahead and do. If we substitute in, we're going to have the opposite of b, so that's going to be a negative what? A negative 4. So we'll deal with that in just a moment. Feel free to speed ahead if you'd like to, but I'm just going to go ahead and write it out as clearly as possible here. Next, we're going to have this b squared. So b again is this negative 4. So I'm going to go ahead and give that a hug, put it in parentheses. Take that negative 4 and square it, and take away this 4 multiplied by a, which is going to be 4, and then c, which is going to be this negative 5. So I'm going to go ahead and substitute those values in as well. Looks like my square root was not quite long enough, so let's go ahead and make that a little bit longer here. And this is going to be all over what? All over 2 times a, so 2 multiplied by a, which is 4. All right, now let's go ahead and start simplifying this a bit. So when we have the opposite of negative 4, that's just going to be positive 4. So it's going to be positive 4 plus or minus, and let's see what is going to be in this square root here. Well, it looks like we're going to have negative 4 squared, which is positive 16. And then let's see, we have a negative 4 multiplied by a positive 4 multiplied by a negative 5. So I think that's going to be negative 16 times negative 5, or positive 80. So we're going to go ahead and add 80 to the right side of that radical inside there. And then all of this is on top of what? Well, 2 times 4, that's going to be equal to 8. Let's go ahead and add this 16 plus 80. 16 plus 80 is going to be 96. So we're going to have 4 plus or minus the square root of 96. And this is all going to be on top of 8 right now. Alrighty, so now we have this radical of the square root of 96. We got to see if there are any perfect square factors hidden inside of it. Now for the square root of 96, I believe what we can do is break this into the square root of 16 times the square root of 6. 16 times 6 is 96, and 16 is a perfect square. Of course, you can try some other factors as well, but none of them are going to give you a bigger perfect square, but you should go through your factors of 96 to find that 16. The square root of that 16 is going to be 4, so this is going to simplify to 4 times the square root of 6, or 4 root 6. So let's go ahead and write this. This is going to be 4 plus or minus this 4 root 6, and this is all on top of 8. Next, what we're going to want to notice is that we can divide all of these values by 4 here, because that's a common factor of all of them. So if we divide all of them by 4, we're going to get 1 plus or minus 1 root 6, or just the square root of 6. Get rid of that invisible 1, and 8 divided by 4 is going to equal 2. All right, so if we're going to write our solution set here, what we can do is we can write, let's see, 1 minus the square root of 6 over 2. That would be an exact solution. And then we have 1 plus the square root of 6 over 2. So these would be the two solutions, and they're both irrational. Here is number 5. For number 5, we have 6x squared minus x minus 15 is equal to 0. Let's see, can we solve this by square roots? Well, if we take a look at this middle term here, we see that b here is equal to negative 1. So solving by square roots is not what we're going to go by. But what about factoring? Let's go ahead and see. I'm going to use my method here. I'm going to say 3x and 2x, because those multiply to get 6x squared. For 15, let's maybe start with a negative 5 and positive 3. Again, it's just kind of a quick guess and check method. That's pretty quick if you get the hang of it. If you multiply across here, this is going to be negative 15x plus a positive 6x. That's negative 9x. That's no good. But if we multiply diagonal, this is going to be 9x. This is going to be negative 10x. Now, 9x minus 10x is the negative 1x in the middle that we want. So if we go ahead and make these our outers and make these our inners, we should have a factored trinomial, right? So let's go ahead and open up some empty binomials here. So let's go ahead and create those and set this equal to 0. Okay. Now it doesn't matter, but I'm going to start with this 3x and 3. Let's go ahead and pair those up as our outers. And you can do the inners if you want, but let's go ahead and put these on the outer locations. And then we have this 2x and -5. Let's go ahead and put the -5 in the first binomial because it's a constant, and put our 2x at the beginning of our second binomial. Again, if you're still a little skeptical, let's go ahead and foil this. So this would be 6x squared, which we like. This would be positive 9x and negative 10x, which combines to make negative 1x, or negative x in the middle, which is also what we want. And then negative 5 times positive 3 is negative 15, so everything checks out here. Now, what will make each of these binomials equal to 0? So for this one, we have this 3x minus 5. Well, what will make this equal 0? Well, we can solve that by just setting it equal to 0. Go ahead and add 5 to both sides. If we do that, we're going to get that 3x is equal to 5. Then we can go ahead and divide both sides by 3. And if we do that, we're going to see that x is going to equal 5/3. That's going to be one of our solutions. Now, what's going to make the other binomial equal to 0? Well, we can go ahead and solve that by just setting it equal to 0 to find out what makes it 0. Go ahead and take away 3 from both sides. Okay. If we do that, then we can have this 2x is equal to negative 3. And then finally divide both sides by 2 here and find out that x is equal to negative 3/2. And so this one was one that we could solve by factoring, and our two solutions here are going to be negative 3/2 and positive 5/3. So two rational solutions here that make this quadratic equation true. Here's number 6. For number 6, we have x squared minus 6x plus 3 is equal to 0. Let's start by seeing if we can solve by square roots. Now, we have a b value here of negative 6. Now, that's not going to be very nice to solve by square roots, but what about factoring? So we have x and x, that's going to multiply to get x squared, and then we need two numbers that multiply to get to positive 3 that add to negative 6, so they're both going to have to be negative here. I think 3 is prime, right? So we can only have negative 3 and negative 1, so if this doesn't work, then it can't be factored. This will be negative 3x and negative 1x if you multiply, and those add to get negative 4x, and that's not what we want. Even if we go diagonal here, we're still going to get negative 4x, so this is not factorable. Next, I would see if we could solve by completing the square. Now, if the b value is even, then it's definitely possible here. So again, b is negative 6 here, and that's an even number, so it's easy to take half of that and then square it. And so I think that's what we're going to go with here. So to complete the square, remember we're going to start by isolating our constant, move it to the other side. Once we do that, we're going to have this x squared minus 6x, and that's going to equal the negative 3, but remember to leave a little blank there if you want to save yourself a little bit of work, because we're going to complete the square. Now to complete the square, we take that b value of negative 6. I'm going to do this on the side here. We're going to take half of it, and then we're going to go ahead and square that, and that's going to complete the square. Half of negative 6 is negative 3. If we square negative 3, that's going to equal positive 9. So by completing the square, we're going to do that by adding 9 to both sides of this equation. If we've done this properly, then we should be able to factor this perfectly into two identical binomials. So what are they going to be? Well, it's always going to be the square root of the first term, so the square root of x squared is x, and then it's always going to be the square root of the last term of 9, and it's going to be 3. Because we have negative 6, we're going to have a minus 3 here, and we're going to have another x minus 3. So we have the two negative 3's multiplying to get positive 9, but the negative 3x and negative 3x that they'll form from the outers and inners will get you the negative 6x. On the right side, negative 3 plus 9, that's equal to positive 6. Condensing the left side, we can just write the quantity of x minus 3 squared, and that's equal to the 6 on the right side. Okay. Now we do have a perfect square on the left side, which is nice because we can take the square root of that to get rid of the squaring, the inverse. And then if we go ahead and do that, we're left with this x minus 3 on the left side, and on the right side we have plus or minus the square root of 6. You should try to see if you can simplify that square root of 6, but I don't think we can just because 6 only has factors of 1 and 6 and 2 and 3, and none of them are perfect squares besides 1, but the square root of 1 doesn't really help us simplify at all. Finally, let's go ahead and add 3 to both sides of the equation to isolate x. And so we can finally have x alone and say that x is equal to this positive 3 plus or minus the square root of 6. And then if we go ahead and write this in set notation, the numbers that make this equation true, we're going to have this 3 minus the square root of 6, that's irrational, and we have 3 plus the square root of 6, which is another irrational solution, and those would be the two solutions that make this quadratic equation true. Let's try number 7. For number 7, we have this equation of 6x squared minus 64 is equal to 0. Now, if we were going to write this with the b term, it would be 6x squared plus 0x minus 64 is equal to 0. So notice that in this particular equation, b is 0, so we can solve by square roots. If we want to solve by square roots, let's go ahead and isolate x squared the best we can first. We're going to start off by adding 64 to both sides of the equation. When we do that, we have this 6x squared is equal to 64 on the right side of the equation. Then we can go ahead and divide both sides by 6. And if we divide both sides by 6, we're going to have 1x squared, or just x squared, and that's going to equal 64 over 6. Just go ahead and keep that as an improper fraction for now. And then we can go ahead and isolate x completely by taking the square root of both sides over here. So on the left side, we're just going to have x alone here. And on the right side, we're going to have plus or minus because we're taking the square root here. And then we have the square root of 64 on top, which is going to be 8. And on bottom, we have the square root of 6, which is not going to be rational. So we're just going to keep it as a square root of 6 for now. Now, hopefully you have learned that we don't typically have an irrational value in the denominator, so we can go ahead and multiply this value by the square root of 6 over the square root of 6, since essentially that's just equal to 1, right? So that's using the identity property of multiplication, so we're not changing the value here. If we go ahead and do that, then we're going to have plus or minus, and then on top 8 times the square root of 6 is just going to be 8 root 6. And in the denominator, the square root of 6 times the square root of 6 is just equal to 6, or the square root of 36, which is still 6. And so we can go ahead and write x is equal to plus or minus the square root of 4 root 6 over 3. And so writing this in set notation, we can say our two solutions are going to be negative 4 times the square root of 6 over 3, as well as a positive 4 root 6 over 3. These would be our two solutions. Alright, here is one final quadratic equation. For number 8, we have x squared minus 7x plus 8 is equal to 0. Let's go ahead and see if we can solve by square roots. We can see here that b is equal to negative 7, so that's a no-go for square roots. Now, what about factoring? Well, it's kind of nice how a is 1 here, so factoring is always a nice thing to do when a is 1. So x and x make x squared. There's no options for that one. We need two numbers that multiply to 8 that add to negative 7, so they both have to be negative. So 8 doesn't have too many factors. We can try negative 4 and negative 2. That would be negative 4x and negative 2x combined. That would be negative 6x. That's close, but that's not what we are looking for. Going diagonal won't change anything, so if we keep the x's here, I think the only other thing we could try is negative 8 and negative 1. If we go across here, it's negative 8 and negative 1. That makes negative 9x, I believe, and that's not what we want either. So this is not factorable. The next thing to try is to see if we can solve by completing the square. Notice how this b value is equal to an odd number. So if we were to take half of this, that would be 3.5, negative 3.5, and you have to square that, or you have to square negative 7 over 2, and that gets very complicated. So you could solve by completing the square. It's just very tedious and time consuming. You have to deal with a lot of fractions. So based on all of those reasons, let's go ahead and solve this by using the quadratic formula. So let's start off by identifying our a, b, and c values. A is 1. We can see here that b is negative 7, as well as c here is equal to positive 8. Now let's go ahead and substitute each of our a, b, and c values into the quadratic formula. Now if we go ahead and clean this up a little bit, we have the opposite of 1, that's going to be negative 1. Then we have plus or minus here, and then let's see what's inside this radical. Now negative 7 squared, that's going to be positive 49. Negative times negative is a positive. And then a negative 4 times a 1 times a 8 should be just negative 32. So we're going to take away 32. And in the denominator, if we clean this up a little bit, 2 times 1, that's just going to be 2. Now, what else can we do to simplify here? Well, we have negative 1 plus or minus, and then for the 49 minus 32, that's going to be 17. That's a prime number, so we can't simplify that radical at all, which is, I guess, kind of nice because we don't have any more work to do if you notice it's a prime number. And so I think we're pretty much done here. Our two solutions we're going to go ahead and write in set notation. We have negative 1 take away the square root of 17. That's going to be over 2. And then we have this negative 1 plus the square root of 17, and that is also over 2. So these would be our two irrational solutions. Alrighty, so there you have 8 different practice problems on solving some quadratic equations. Now all of these happen to be written in standard form. If they weren't written in standard form, you could just move some things around to get it into standard form, but maybe if you'd like to see some videos or worksheets, practice problems on those types, feel free to comment down below and I can try to make some to help you out. So hopefully you found this video helpful. If you did, please consider giving the video a thumbs up and sharing it with a classmate or friend who might also find it helpful. And as always, keep up the great work that I know you're already doing, and I'll see you in the next one.